Hello there, Mr. Sutton here, bringing you the IM315 classwork solutions on Systems Word Problem Practice. For this one, we have a jar containing 40 coins with dimes and quarters and a total value of $4.90. We want to know how many of each kind of coin are there. So for this one, this is going to be a systems problem. We have two different pieces of information about the same quantities. We're going to start by creating variables to represent the things we're looking for. We want to know how many dimes there are, so we'll let D represent the number of dimes, and we also need Q to represent the number of quarters. Let's create two equations now using these variables. So they told us that we had 40 coins. We know that if we take the number of dimes, D, and add to that the number of quarters, Q, that should all add up to 40. So we can say that this equals 40. So there's one equation. This by itself is not enough to tell us the dimes and the quarters, though. We need one more equation to kind of play this one off of. So that's the value that we're going to use there, 490. So we know that if we take the value of all the dimes, which is 10 cents times the number of dimes, so 10D, and I add to that the value of all the quarters, so 25 cents times Q, that should all add up to this grand total of $4.90. which I'm going to express as 490 because I've already expressed my variables here in terms of cents rather than dollars. So at this point, we've expressed our quantities with two equations, and it's just a matter of solving this system of equations using either substitution or elimination. Now, substitution wouldn't be too bad on this one. You just have to isolate D or Q in this first equation and then plug into this other one. But I chose to go with the elimination. So I'm going to get rid of D, and to do that, I'm going to multiply this first equation by negative 10, and then add that to this equation over here. So negative 10 times this equation, we've got negative 10D minus 10Q equals negative 400. And now adding these two equations together so that those 10Ds cancel out, I end up with 15Q on the left side, that's 25 minus 10Q, equals, on the right side, this is going to be 90. Dividing both sides by 15, we're going to end up with Q equals 6, so that's 6 quarters. Now to find the number of dimes, we can plug Q back in, plug in 6 for Q. Probably this equation is a good one to use because it's already pretty simple looking. So plugging in 6 for Q over there, we have D plus 6 equals 40. Subtracting 6, that's going to give us 34 dimes. Now here's a problem that makes me smile. A group of students takes their math teacher out for lunch. Aw, that's so sweet of them. If 5 have hamburgers and 3 have pizza slices, the bill is going to be $24.25. If 3 have hamburgers and 5 have pizza slices, pretty much the reverse of our first situation, then the bill is $21.75. We want to know the price of a hamburger and a pizza slice because, I mean, you can't just look it up on the menu, right? So let's do a little math to find those prices. First, let's come up with some variables for the things we're looking for. The price of a hamburger, we're going to represent that with H, and the price of a pizza slice we'll represent with P. So one equation that I can write out of this, using the value of that first bill with 5 hamburgers and 3 pizza slices, if I take the value of all the 5 hamburgers, that's going to be 5 times the price of 1 hamburger, so 5 times H. And I add to that the price of the 3 pizza slices, so that's going to be 3 times the slice of 1 pizza, 3 times P. If I add that together, then that should all add up to 24.25. And I can set up a separate equation now for this other situation. So we have 3 hamburgers plus 5 pizza slices, so 3H plus 5P. And this time, this is going to equal 21.75. And at this point, we just use substitution or elimination to come up with a solution for both of these. Okay, so I'm going to go ahead with elimination on this one. I'm not sure it's really going to be any faster than using substitution, but substitution, I know for sure I'm going to be ending up with decimals. Elimination, maybe there's at least a chance I can avoid that. So I have to figure out if I'm eliminating the H or the P for my first step here. I'm going to try to eliminate the H's. I have a 3H over here and a 5H over here. 3 and 5 both go into 15, so I want to make one of these into a 15H and the other into a negative 15H. To start this process, because I got to start somewhere, I'm going to multiply this second equation by 5. That'll give me a 15H. So I have a 15H plus 25P plus whatever 21.75 times 5 is. Time to get the calculator. So 5 times 21.75 comes out to 108.75. All right. And now I have to multiply this first equation by negative 3 so that I end up with a negative 15H to cancel out the positive 15H. So negative 3 times this thing here, we have a negative 15H minus 9P equals whatever negative 3 times 24.25 is. Let me go to the calculator for that. So we have negative 3 times 24.25, and that's going to give us negative 72.75. And at this point, I can just add these two equations together to cancel out those 15H's. So on the left side, we have 25P plus negative 9P, giving us 16P. And over here, we have 108 plus negative 72.75. You could use a calculator, but these 7 5s are going to be going away. We really just have 108 minus 72, which is, let's see, 36. At this point, though, we have to divide 36 by 16 to get P. So let me do that on the calculator, because we're going to end up with a decimal. So 36 divided by 16, that ends up being 2.25. So all of this is saying the slice of a pizza is $2.25, which seems reasonable. Okay, now we need to find the burger price. So let's plug in 2.25 for P in one of these equations. I'm going to use this equation up here. Really, one is as good as another at this point in the problem, but you got to plug it in somewhere. So we have 5H plus 3 times 2.25 equals 24.25. So this is 5H plus 6.75. And if I subtract that from 24.25, let me use the calculator here just to be on the safe side. I mean, if I've already started using it, I might as well get a little bit more mileage out of it. All right, pressing enter there, we have $17.50. So that's the price of 5 hamburgers. Dividing that by 5 gives us the price of 1 hamburger. So on the calculator, we end up with $3.50. For this problem, we have the U.S. Treasury deciding to introduce a new coin called a septum worth 7 cents. Someone's been playing a little bit too much Elder Scrolls over there at the U.S. Treasury. If Tiber has a total of 42 quarters and septums totaling $5.28, we want to know how many of each coin he has. All right, so let's represent each of these quantities that we're solving for with a variable. We'll say that the number of septums will be represented by S, and then we'll use Q for the number of quarters. So they told us we had 42 quarters and septums, so that's combined there. So we can say the number of septums, S, plus the number of quarters, Q, should add up to 42. So there's one quick equation we can use. We also need another equation, though, because one usually is not enough if you're trying to solve for 2 different variables. So for our other equation, we'll use this combined value of $5.28. If we take the value of all the septums, which is going to be 7 cents times the number of septums, so 7 times S, and we add that to the value of all the quarters, so that's going to be 25 times Q, 25 times the number of quarters. If we add that together, we should end up with $5.28, which I'll represent as 528 because I'm writing everything in terms of cents rather than dollars. Now I'm going to solve this system of equations, and I could go substitution or elimination on this one. Just to make my life easier, though, I'm going to go with elimination and get rid of the S's, just so I'm multiplying by smaller numbers. So I'm going to take this first equation and multiply it by negative 7. That's going to allow me to cancel out the S's. So I have a negative 7S minus 7Q equals whatever negative 7 times 42 is. I believe that's, let's see, 7 times 40 would be 280, times 2 is 14. So 280 and 14 gives us 294, and that's going to be negative. All right, got to add these equations together now so we can cancel out those 7 S's. We also have an 18Q if we add those Q's together on the left side. And on the right side, well, I don't know what this comes out to. Let me just use the calculator to be on the safe side. So 528 minus 294 gives me 234. Okay, take your word for it. And then let's divide that by 18. Since I've already got that loaded into my calculator, let me just quickly press answer divided by 18 and enter. Gives me 13. So that is 13 septums. No, 13 quarters. Q. Q is going to be 13 quarters that we have in this collection of coins. Now we need to find the number of septums. So let's plug 13 in for Q. Back in this equation here seems like a good idea. It's the easiest one out of all the equations I have available. So we have S plus 13 equals 42. Subtract 13, and that's going to be 29 septums. For this one, we have the number of pounds of cashews that Deja buys for her restaurant is 12 less than 3 times the number of almonds that she buys. Okay, that doesn't really tell us a whole lot because we don't know how many almonds she bought. Maybe there's more information, though. Almonds are $5 per pound and cashews are $8 per pound. That seems reasonable since cashews are way better. And Deja spends $716 total on nuts. Based on this, how many pounds of each type of nut did she purchase? So let's start by defining some variables for the things we're trying to solve for. So we're trying to solve for how many almonds and how many cashews. I'm going to let A represent not just the number of almonds, the number of pounds of almonds. That's what's going on here. And we'll say C represents the number of pounds of cashews. Okay, so we need some equations that tie all this together. Now, they told us that the number of pounds of cashews, which is C, equals 12 less than 3 times the number of almonds. Well, 3 times the number of almonds, that would be 3 times A. And they said 12 less than that, so we have to do 3A minus 12. So this gives us a relationship between A and C. By itself, this is not enough, though, to figure out either quantity, so we need one more equation. We're going to use this information down here about how much each type of nut is worth per pound and how much total Deja spends on these nuts. So the $716, this is made up of the value of the almonds plus the value of the cashews. The value of the almonds is going to be the $5 per pound, $5 times the number of almonds, so times A. So 5A, that tells us how much all the almonds cost us. And we're going to add to that the cost of the cashews, which is going to be 8 times the number of pounds of those, so 8 times C. And if we add all that together, that should add up to $716. So now we have a system of equations that we can solve. And as always, you can do this with elimination or substitution. In this particular case, I think substitution is going to be easier because you already have C isolated in this first equation. So in order to get that substitution process rolling here, I'm going to take 3A minus 12, and I'm going to replace C with that over in this second equation. So I'm going to write 5A plus 8 parentheses 3A minus 12. And now that I have only A's in this equation, I can go ahead and solve for A just using normal algebra. So let's distribute this 8. That's 24A minus 96. Combine some like terms. We've got 29A minus 96 on the left side. If I add 96 over to the right side, let's see here. If I added 6, that would be 722. Add another 90, that's going to be 812. And now we have to divide that by 29. Well, I'm going to the calculator for this one. So 812 divided by 29 gives us 28. So that's telling us that we have 28 pounds of almonds. That's a whole lot of almonds. But again, this is for a restaurant, so who knows, maybe they actually need that many. All right, let's find out how many cashews we have. Since we know the number of almonds, A, we can plug in 28 for A in any of the equations that we started with. I'm going to go with this equation over here because C is already by itself, and that's what we're trying to find now. So plugging in 28 for this A right here, we've got 3 times 28 minus 12. 3 times 28, that's going to be, let's see, 84. And if I subtract 12 from that, that's going to be 72. So in real life terms, that means we have 72 pounds of cashews. For this one, we have 4 plumbers and 5 helpers earning $1,092 on one day. Another day, with the same number of hours and same rate of pay, we had 5 plumbers and 6 helpers earning $1,344. We want to know how much each of them gets paid each day. So let's set up some variables for the things we're solving for. I'm going to let P equal the pay for the plumbers on a given day, and then H will be the helper pay. So we have two equations we can set up based on the information from these two different days. On day 1, 4 plumbers and 5 helpers got this much money, $1,092. So if we take the amount of money that the 4 plumbers got paid, that's 4 times the plumber pay, so 4 times P, and add to that the helper money, so 5 times H, that should add up to $1,092. We can do the same thing with day 2. So we have 5 plumbers, so 5P, plus 6H for the 6 helpers. That should add up, that should equal 1,344. All we have to do at this point is solve using substitution or elimination. And I'm pretty sure elimination is going to work better, although both of them are going to be kind of tricky on this one just because of the types of numbers involved. So for elimination, we have to decide if we're getting rid of P or H. And it doesn't really matter how you go. I don't think anything's going to be faster on this one, but I'm just choosing to get rid of H. I'm making a decision. So if I want to get rid of H, the smallest number that 5 and 6 both go into is 30. So I'm going to multiply each equation by something to give me a 30H and a negative 30H so that those H's will cancel out when I add the equations together. So I'll start by taking this equation here and multiplying it by 5. So that'll give me a 30H over here. So we have 25P plus 30H equals, well, now I need the calculator, 5 times 1344. So that ends up giving us 6,720. And now let me take this other equation here and multiply this by negative 6. That gives me a negative 24P, which is actually going to work out nicely when we add these. We also get a negative 30H, which was what we were trying to get in the first place. And then we have 6 times 1,092, or actually negative 6 times that. So let me do negative 6 times 1092, and that gives me negative 6,552. Time to add these equations together. So that cancels out these 30H's. And then 25P minus 24P, or plus negative 24P, that just comes out to 1P. So this is really good because whatever is on the other side of the equation now is going to be the value of P. So we need to do 672, or 6,720 minus 6,552. Let me do that on the calculator. And that's going to come out to 168. So that's how much a plumber gets paid in one day in this problem. To figure out how much the helpers are getting paid, let's plug in 168 for P, and I'll do that in this equation over here. I could have also used this second equation, but there's more space over here, so I'm doing it over here. So we have 4 times 168 plus 5H equals 1092. Let me multiply 4 and 168 on the calculator. So that comes out to 672. And then I'm going to go ahead and subtract that from 1092. So 1092 minus 672. That's 420. And then if I divide that by 5, I've already got the calculator out, so I might as well just do it on the calculator. That comes out to 84. So that's $84 that the helper gets paid. For this coin problem, we have Jeremy, who has 5 more dimes than he does nickels, and a total value of $3.35. Don't spend it all in one place. We want to know how many nickels and dimes Jeremy has. All right, so let me set up variables to represent the things I'm solving for. We have the number of nickels. That's going to be n in this problem. At least that seems like a good variable to use. And for dimes, number of dimes, I'm going to go with a d. So let's set up some equations now. They said Jeremy has 5 more dimes than nickels. So this means that the number of dimes, d, is going to be the number of nickels, n, plus 5, because it's 5 more dimes than nickels. And they also told us we had a total value of $3.35. So the total value of the nickels, so that's 5 cents times n, the number of nickels, plus the total value of the dimes, 10 times d, that should all add up to this total overall value of $3.35. I'm going to write this as 335 just to keep everything in terms of one unit, namely cents. Now it's time to solve. So with substitution or elimination, either one's going to do it for me on this. But I noticed that I already have D isolated in this first equation. So I'm thinking substitution is going to work a little bit faster for this one. Let me take n plus 5 then and replace the D over here with n plus 5. So we have 5n plus 10 times n plus 5 parentheses. Distributing that 10, we've got 10n plus 50 in there. And then we can combine those n's to get 15n plus 50. Subtracting 50 from both sides, that's going to be 285. And now I have to divide that by 15, which I'll do on the calculator just to be on the safe side. So 285 over 15 gives me 19. So that's 19 nickels. N equals 19 nickels. To find the number of dimes, let's plug in 19 for n in this equation up here because D is already isolated in this one. So we have 19 plus 5, which gives us 24 dimes. On this problem, we're going out to lunch. A group of students is anyway. If 2 of them had hamburgers and 5 had sandwiches, the bill would be an even $8. If 5 had hamburgers and 2 had sandwiches, then the bill would be $9.50. So we know that the hamburgers are a little bit more expensive than the sandwiches, but we'd like to know specifically the price of each type of meal. Maybe the restaurant isn't giving you a menu, or maybe it's online but you're out of Wi-Fi or something. I don't know. All right, so let's come up with variables to represent the price of each type of meal. We'll say the hamburger variable is going to be H, that's the price of a hamburger, and we'll use S for the price of a sandwich. Okay, so we can set up 2 equations based on these 2 hypothetical situations. If 2 have hamburgers and 5 have sandwiches, the bill is $8. So we can say that the value of the hamburgers, 2 times H, 2 times the price of a hamburger, and the value of the 5 sandwiches, 5 times S, if we add those together, that should add up to $8 total. We can also set up an equation using our second situation here. 5 hamburgers, 5H, plus 2 sandwiches, 2S, should give us a bill of $9.50, which I'll write as 9.5. At this point, we just have to solve this system using substitution or elimination. So lots of decisions to make now. I'm going to go with elimination. Substitution looks like it's going to involve even crazier decimals than I already have. So let me eliminate the S's. That's what I'm going to do. To start that process, I need a number that 2S and 5S will both go into, like 10S and negative 10S. So let me start by multiplying this equation here by 5. So that'll give me 25H plus 10S equals 9.5 times 5. Well, let me use the calculator just to be on the safe side. So 9.5 times 5 gives us 4750. All right. And now I have to multiply this other equation by negative 2 so that I get a negative 10S to cancel out my 10S. So I've got a negative 2 times everything in this equation. So negative 4H minus 10S equals negative 16. Let me go ahead and add those equations together. So let's see here. The S's are canceling. This is good. We just have the H's on the left side. 25 plus negative 4H is going to be 21H. And on the right side, this is going to add up to $31.50. So the price apparently of 21 hamburgers, if anyone's ordering that many, is $31.50. To find the price of 1 hamburger, let me go back to the calculator, and I'll do 31.5 divided by 21, giving me 1.5. So the price of 1 hamburger is only $1.50. Nice. Maybe it's one of those McDonald's dollar menu kind of deals. Who knows? All right, let's find the price of a sandwich. So if I plug 1.5 in for H in one of these equations, let me just use this equation over here. That should allow me to solve for S. So we have 2 times 1.5, which I know is 3, so that works out nicely. If I subtract that from 8, now I have 5S equals 5. Dividing by 5, we find the price of a sandwich to be only $1. Boy, these are like 1940s prices or something.